In this video, we are going to discuss our Lab 7. So this Lab 7 is same with our Lab 6, but this time we are utilizing the multi-module programs, which means that we are utilizing two files to work together in order to get our desired result. So the desired result is the factorial of the input of our user. So let's get straight into line 14, which is the global get input. So as you can see, we set our function get input into global so that we could utilize it in between two files in our CMake. Next, in line 19, we simply store our EBP to our stack. In line 20, we set the value of EBP to be ESP. In line 22 to 23, we just simply printed out the first message, or it is shown at the beginning of our program, which is the message enter your number to calculate its factorial. In line 25, we call this function in order for us to read the integer or the input by our user. In line 27, we set the value of EBX into EBP plus 12. So this, we added 12 in the current value of EBP to get the address 2 levels below the top of the stack. In line 29, the value or the address of EBX is set to be equal to EAX, or the input of our user. So in our EBX, the value for that will be the input of our user. In line 31, we just simply remove the EBP from our stack, and in line 33 to 35, we just simply exit the function and go to the relative to the calling instruction. So we're done now in our get input. Now we're going to continue in our get output, or this block or this subprogram is responsible for showing or printing out the result to our user. So in line 42, we also set our get output to be global, and in line 45, we store our EBP to our stack. In line 46, we change the value, or we change the value of EBP, same with ESP. In line 47 to 48, we just simply print out a string message, which is the factorial of. And in line 50, we added 16 to the current address of ESP that will be stored in our EAX, so that this will be the 3 layers below the value pointed by ESP. And then we call in the print integers. So we are going to get the function from this one, or the value from this one, and will be printed out. So for this one, actually, this is the input of our user. Since it's plus 16, so 3 layers below is the input from our get input, this one. So what we got here will be printed out in our ESP plus 16. In line 53, we just simply printed out the word is. In line 56, we changed the value of EAX to be the address ESP plus 12, or the value that we got from our ESP plus 12. And this will be the 2 levels below the top of the stack, which is the result for our factorial. So ESP plus 16 is the input, and ESP plus 12 is the result. And call print new line, so just print a new line, and again we remove the EBP from the stack, and same with the leave in red. In line 67, we have this subprogram named go solve, and this also is set to be global. Same with the previous functions or subprograms, we store first the EBP to the stack and change its value, same with the ESP. Now in line 74, we store the value of EAX to be the address of EBP plus 12, which is the value of second level of the stack. In 76, we compare the value if it's equal to 0. If it is, then it will go exit subprogram. But if it's not, it will just continue to decrease. So the value will be decreased by 1. The value of EX will be decreased by 1. And the value of EX will be pushed in our stack. And again, we are going to repeat this whole process, or this whole block. And we are going to get or remove the value ECX to our stack and move the value of ECX to EAX. And then after that, we are going to multiply the value that we can find in our 12. So this will be the, let's see, when we do the factorial, this is the latest product of our factorial. So this may be not equal to 0 or not the final value of our factorial, since if it is the final value, then it should be equal to 0 and it will go straight to coexist. But because it's not, then it will go to our EBP plus 12 address. In line 92, we move the value of our EBP plus 12 into EAX. So now the result that we got from here will be stored in our EAX. And then we're going to jump in our exit. So in our exit, so we have this EBP is equal to the last value pushed in the stack, or this is the final result. So closing function and return to the caller. In line 105, this is now the factorial itself. So in line 109, we have this push EBP. So we are going to stack the EBP, or we are going to store the EBP to the stack and set its value into ESP. Then after that, we store our 16. So 16 now is the result, and 12 is the partial value of our factorial. So in line 116, we store the value of EAX to the stack. So the EAX now is the partial value of our factorial. So this is not the final value of our factorial. In line 118, we call the function goSolve. So as we discussed here, this will be repeated until it reaches the value 0. If it reaches the value 0, then we'll know that the factorial is thoroughly done. And same with the leave and ret. So let's go straight in our cmain.asm. So in our cmain, we use this function extern so that we could call on the subprograms that we have in our cfactorial.asm file. So after calling this one, we are going straight in our main function. So for our line 14 to 15, in our line 14, we push the value of our input in our stack. In line 15, we call on the get input. So the get input function, which is to get the input from our user. And then in line 16, we add ESP plus 4 so that we could remove the input from our stack. In line 17, we call in the result factorial function, which is we got from here. It's not the result factorial, it's the we got from here. So this is one of the variables that we use as a storage. So we store the value of result factorial to be equal to 1, and in line 19, we store the value of our result factorial in our stack. And in line 20, the address of the input will be stored in our stack also. In line 22, we call on the factorial function to get the factorial. In line 24, we remove the top 8 bytes of the stack. In line 26, we set the value of EAX to be equal to the result factorial to the address of the result factorial. In line 29, we get the address of the input and add it to our stack. Same in line 30, but this is the result factorial address. In line 32, we call on our get output function, which will be printing out the result. And in line 34, we add again the value of ESP with 8 so that it could remove the 8 bytes of the stack so that it could clear up. And in line 36 to 39, we just simply set back the registers to their original values, which are 0, and the pop A, which is stack, is emptied, and leave and ret. And that's all for the program. Now let's see if this will work. Now we're going to try to compile our two subprograms, the main and our another ASM file, and see if it'll give us the desired results that we're expecting. So d of type c factorial dot ASM c main, then colon our driver, c main dot o, driver dot c, and ASM io dot o. After finally compiling it, we could check if it will give us the results. C factorial. So let's try to get the factorial of 9, and this gives us 362,808. So this is correct. Now let's try to get another number. Let's try to get the factorial of 5. And as you can see, this program gave us the desired results that we're expecting. And that's it for this video. Thank you for watching.